and some instruction to go along with example problem 1 in section 2.5. Add rational numbers. The sum of two rational numbers with the same denominator. Let's let the fraction a over b be a rational number, and the fraction c over b be a rational number. So they could be any rational numbers. If we're adding these two rational numbers, a over b plus c over b, then our sum will be a plus c over b. The sum of any two rational numbers with different denominators, let's let a, b, c, and d be integers. Therefore, a over b and c over d could be any rational numbers. In that case, a over b plus c over d will equal a times d plus b times c over b times d. Note the difference, the different denominators. So here's an example. Let's evaluate 1/5 plus negative 2/3. So we probably have a technique that we like to use. Let's check out this example. So we'll see 1/5 plus negative 2/3 equals, well, this tells us to take a and d and multiply those. So for us, that's 1 and 3. So 1 times 3 plus, and then take our other cross products, the other numerator and denominator across from one another. So that would be plus negative 2 times 5. And to write all of that as a fraction with the denominator of 5 times 3. All right, further simplifying, we'd have 1 times 3 plus negative 2 times 5 over 5 times 3. And again, further simplifying, 3 plus negative 10, negative 7 over 15. All right, since I'm in the area, let's check out this student hint. If m divided by n, or m over n, is any rational number, then the negative of m over n equals negative m over n, which also equals m over negative n. So considering that, let's use m equals 1 and n equals 2. So negative 1 over 2. The idea here is that the negative is placed in line with the fraction bar, resulting in a negative value. Now that equals negative 1 over positive 2, because as we know, a negative divided by a positive, the signs don't match, and so we'd have a negative result, which also equals positive 1 divided by negative 2. So this may seem like obvious stuff to us, but it's good to keep in mind. Sometimes students will see the negative sign in line with the fraction bar and not know whether they should apply that to the numerator or denominator, or even both sometimes. It turns out you shouldn't apply it to both. That would result in negative 1 over negative 2, which equals 1/2. All right, and negative 1/2 certainly does not equal positive 1/2. It turns out that the negative equal with the fraction bar, or in line with the fraction bar, can be placed with the numerator or the denominator, just not both. In certain cases, it'll be nicer to have a negative numerator. In other cases, a negative denominator. In some cases, it doesn't matter, and we can just leave it in line with the fraction bar. All right, so this has been good. We completed this, this rational number addition. We found a sum. We used the books technique. We talked about some negative values, negative numerator, negative denominator, or negative with the fraction bar. But let's confirm. I mean, maybe the book's crazy and this doesn't work. Let's use a technique that maybe we're more familiar with, which is finding a common denominator and then simply adding or subtracting across the numerator. So let's check it out. 5 and 3, not currently common denominators, but if we look for the least common multiple of 5 and 3, we find that to be 15. And therefore, we need to multiply 1/5 times 1 but one written in a special way that we get to determine in order to arrive at some fraction with a 15 for a denominator. Similarly, we're going to do the same sort of thing with negative 2/3. We're going to multiply that by 1, again written in a way that does some work for us or accomplishes a task, to arrive at a fraction with some numerator over a denominator of 15. Then we can add these two together very easily. So let's think about what way should we write 1 in order to arrive at, well, a fraction with a denominator of 15. Well, another way to write 1, how about 3/3? I hope we can all agree that 3/3 equals 1, and therefore multiplying 1/5 times 1, even if it's written this way, it won't change the value of the fraction. It'll just change the way it looks. It'll change the presentation of the number. So check this out. 5 times 3, 15. 1 times 3, 3. And naturally, if we were to reduce 3/15, we'd arrive back at 1/5. So we found an equivalent fraction by multiplying by 1 that accomplishes a task for us. We have a denominator that will soon be a common denominator between our two fractions. So let's do something similar here. Negative 2/3 times 1, but 1 written specifically for this cause or this purpose, so that we get a 15 denominator. How about 5/5? Negative times a positive will result in a negative. 2 times 5 is 10. So to check ourselves before we, let's not get into that, 10/5, 15ths reduces, divided by 5, we become negative 2/3. Excellent. So we have written an equivalent fraction here, or ratio. And now it's just a matter of, well, rewriting. 1/5 plus negative 2/3, we've rewritten that. It would become 3/15ths. 15ths plus negative 10/15ths. Now remember, the negative sign can go even with the fraction bar, it can go with the numerator or denominator. In this case, I think it's best to think of the negative as going right along with the numerator. And then we can think of this as being equivalent to 3 plus negative 10, well, negative 7. Right? Same thing as 3 minus 10. If you have $3 and you have to give someone $10, well, the result would be a debt. You're taking away or owing more than you have. So negative 7 and 15. All right, so that was good. We get the same answer whether we use the books technique or the technique that maybe we are more familiar with. It's good to check things. Here's an example for you. Example problem 1, add rational numbers. So add negative 2/7 plus 3 over negative 5. Well, we want to seek out a common denominator. And at this point, it's up to you. You may use our cross multiple method, seen earlier, or use the least common denominator method. Let's see. 7 times negative 5. This works very well, using the least common denominator method. So we're seeking a number that 7 and negative 5 are both factors of. How about negative 35? So this whole problem can be rewritten as, well, we need to multiply the numerator and denominator here by the same thing. Multiply it by negative 5, so we would get 10 over negative 35. And we're adding. Multiplying by 1, but 1 written as 7 over 7 on the right-hand side, we'll get 21 over negative 35. Fantastic. Simply adding our numerators, 10 plus 21, denominator stays the same. And our final check, see if this fraction reduces. Finding that it doesn't, we move on. And now guided practice to go along with example problem 1. Add rational numbers. Well, here are our numbers to add. Negative 1 over 9 plus 2 over negative 5. And we have our tiles again at the bottom to introduce throughout this problem. So let's check it out. We have negative 1 over 9 plus 2 over negative 5. We can see this denominator, and 9 times negative 5 and negative 5 times 9. That's great. We're just multiplying these. We know that if we multiply the denominator by negative 5, we also need to multiply the numerator by negative 5, right? Because we're really thinking of this as multiplying by negative 5 over negative 5. And so we can fill in this set of parentheses here. What do we fill it in with? Is it 18? No. How about negative 5? Negative 1 times negative 5. Great. Along those same lines, negative 5 times 9. Well, if we multiply the denominator times 9, we better multiply the numerator times 9 as well. All right, and then moving down, let's simplify. So our denominator stays the same, but our numerator will simplify. Note the justification at the right as it walks us through the steps. It says to rewrite using a single denominator. I think that's supposed to say denominator, a single denominator. So we're combining these two fractions into one, so our tiles don't really change much. We just combine two fractions into one. Next it says multiply all products. So negative 1 times negative 5 is 5, and 2 times 9 is 18. Now simplifying, or adding, 5 plus 18 all over negative 45. Let's see, 23 and 45, can that be reduced? Now some factors of 23, well, 1 and 23, right? 23 is a prime number, meaning that 1 could be the only common factor unless 23 itself is a factor of 45, and it's not.